Alright guys, wave goodbye. We are going to do constructive and destructive interference. What you're going to do is you're going to take your worksheet and you're going to pick three colors. Two of them are going to be for your waves, both your waves. And then the third color, which I'm going to go ahead and make, let's see, what's a nice, easy color, green. This is going to be compound, my compound wave. A compound is your combination of the two. So when the waves, as you know, like waves, they can either constructively interfere when they have the same amplitude, positive or negative. So right now they're both above the line, so this would be positive. Down here would be negative. So if they interfere or they take up space at all and they're both on the positive side, they're going to constructively interfere. But this would also be true if they were both on the negative side. So if they're both on the negative side and they overlap at all, they superimpose, they would make constructive interference just in the negative direction. Okay, so I'm going to show you how to kind of calculate some of these things. It's actually pretty easy. Let's go ahead and just take an example here. All right, so these waves are traveling towards each other. You're going to move one step at a time. So on your paper, go ahead and just move your dots over one at a time. You can pick like the foot and just go down to the right, and then take the blue one down and to the left, or whatever color you decide. And then you go ahead and just keep moving them one step forward at a time until they overlap. Okay, so you see how I have two sets of waves overlapping. You're going to take your third color, which I went ahead and made my green. It's my compound or my combination. And I go through and I look and I count the dots. Okay, this is 1. So my compound is going to be a 1. Still, it hasn't changed. 2. But 1 and 1, what happens when I add 1 and 1 together? 1 and 1 makes 2. So I'm going to make, they'd actually constructively interfere and get higher. Okay, 2 stays the same, and 1 is going to be like that. Okay. So what I'm going to go ahead and do now is I'm going to get my third color, my green. I'm going to come in and trace what the combination of these two would end up doing. Okay? So for the most part, they stay the same, but right here where they overlap or they superimpose, they end up combining constructively. Okay, does that make sense? Okay, let's go ahead and do another example. So now they're moving a little bit more. And now they have completely overlapped, right? That's why it looks like all blurry. So I'm going to take my third color, my compound, and go 1 and 1. 1 plus 1 is 2. 2 plus 2 would be 4, so way up here. And 1 plus 1 again would be 2. So now, when I draw my combination wave, look what happened. This is constructive interference, right? Look at that. Crazy, right? Okay. And as they move past each other, okay, so they don't interfere anymore. Let's go ahead and do the opposite way. So let's say I got, so they are moving towards each other. So right now they don't interfere. And then you move them one step closer. And let's go ahead and make some interference happen here. All right, so 0, 1, and nothing. So it's going to still be 1. And then look what we got here, 2 and 0. 2 plus 0 is what? Or negative 2 plus 0 is what? Still negative 2. All right. Positive 1 plus negative 1, so these are minus, right? 1 plus negative 1 gets you 0, so it's actually, they're going to cancel out right here. You're going to deconstruct. Positive 2 plus 0 is going to be positive 2. And then there's no interference here, so that stays. So now here's my combination line here. So I'm going to trace through, and then look, deconstruct, so it goes through the origin here. Up, and up there. So here's my combination. Here's my compound wave here. Okay. So now they move more. They're going to move a little bit more now. Okay, so of course you would move both of these a little bit at a time, right? And look, now they perfectly overlap, but they're going to do destructive interference, complete destructive interference. So 0 plus 0 is 0. 1 plus negative 1 is 0. 2 plus negative 2 is 0. And 1 plus negative 1 is 0. Okay, so my compound wave this time is just going to be nothing. I get complete destructive interference. And if this had been a sound wave, which of course sound waves are going to look like this, right? You got a compression and like a little bit of a rarefaction here, compression, right? So if I wanted to do this with a sound wave, right, the overlap would be two compressions like that, right? So these would combine to make a nice, really loud noise, right? So here's my thick compression. Here's my other thick compression here, right? And of course, if I had staggered them like that instead, now the compressions and rarefactions overlap. This would be like the crest and trough. So these would destructively combine, right? And so you'd end up with no wave. You'd end up with a lighter wave, right? Right, it would get quieter. Okay, so this is something you kind of have to think about. Part of your lab practical is going to be to move to a location to make something get either quieter or louder. And so you want to look to see where the waves are combining constructively, where the compressions are combining. All right, good.